Hi, welcome to class. My name is Don LaFont, Professor Don, and this week in our CTS 1133C A+ software configuration class, we are learning about scripting with an introduction to scripting in Chapter 15. I'm going to go ahead and open that in just a moment, but scripting can be just the basics of programming, can be helpful to turn difficult, or not difficult, but time-consuming processes. If you build a script, you can easily perform those processes without the manual or the time it takes to do it manually. I like to when I first started teaching, I spent a lot of time teaching CTS1100. That's the course at my college where I teach Word, Excel, PowerPoint, and Access. And I learned how to do macros inside of Excel, and I became pretty good at macros. And then my wife had a job where she had to do the same filtering and calculations on the same spreadsheet day after day after day. And I showed her how to build a macro inside of Excel to quickly turn a full-blown spreadsheet into the exact information that she uses over and over again. And she loved me for that. She already loved me, I think, but she definitely loved me for that. We even made a custom group and add the macro button to the custom group, and she just loves opening up that spreadsheet now. It used to be a chore. So scripting is similar to that, something that you can create ahead of time and then run the script, and based on what language. I'm proficient in Python, although I'm still learning, and you'll always be learning when you're learning languages. I'm proficient in Python because Python is a scripting language that we use in Cisco. And as I mentioned earlier, I spent a lot of time teaching Cisco. So my Python knowledge has come in handy and will continue to come in handy with Cisco. Anyways, let's go ahead and let me share my screen, and let's get that PowerPoint out of the way for those of you that want to open up their PowerPoint on your end. I've included a copy of the PowerPoint inside of our classroom. I can probably provide one out on YouTube as well, attach a file. If anybody's interested in that, please let me know, and I'll put my PowerPoint out there. There's nothing confidential about this. I'd be happy to share it with you. Otherwise, just search for Introduction to Scripting, Chapter 15, with the ISBN number of the textbook, and all of the PowerPoints are out on the internet. So here we are in our course. Just wanted to check something. And let's go ahead and start the presentation on the first screen. All right. I'm going to move this window, start the chat room. If any of you have any questions and you're here with me live, please hold those questions until the end of the presentation. If there's something I'm missing, by all means, you can also type it inside of the chat room, and I will respond verbally, probably. But if I ask a question, put the answer in the chat room. That helps me out as well, okay? Almost there. One more moment. And introduction to scripting. Let's go ahead. So this presentation covers changing perspective when troubleshooting, command line basics, and scripting basics. So qualities of a good technician. We start every presentation with talking about the soft skills that technicians need. And this week, they talk about changing perspective when troubleshooting. Sometimes when you're troubleshooting, you get frustrated, or things get frustrating. Try these tips that happen, Try these tips when that happens. Put yourself in the user's shoes. Think like the user instead of thinking like a technician. Ask yourself what another technician would do, or think back to a similar problem and what you did to solve it. This is great experience when you are able to teach as you're troubleshooting if you have the user right there. So I always try to remember that not everybody understands the terminology that we use as nerds, right? We use terminology all the time that's way above the head of most users. For example, just the term script can be frightening to an average user. Menu, saving a file could be a challenge. I remember once I mentioned during the last presentation where she didn't know how to use a mouse. So me telling her to double click, I was already over her head because she didn't know what that term meant, right? So try to put yourself in the user's shoes. Think what level are they on, and then try to think in a way, present the information in a way that would help them to understand. Also, when you think about what another technician would do, maybe I like to bring up other teachers, and I remember how I try to remember how they do things or how they would do things. I forever take classes. I love taking classes at the college level, and I've told you I probably have 100 classes under my belt. But I always try to think of another teacher and how they would go about doing something. And then if I need help, I actually can reach out to them. So I recommend you do the same. If you're running into a problem and you know an expert in the field that you're currently working on, by all means, if you need help, reach out to somebody that you are comfortable with and have that knowledge. We all use Google, of course. You can think of them as another technician, right? Or think back to a problem you may have had in the past. I like to suggest at this point, and I do when I'm always teaching, I should say. I always suggest that students and technicians keep a tech notebook, and that tech notebook, put the important things in the tech notebook. Once you get out to the field and you have stacks of equipment in multiple locations, make a tech notebook for each area, so that you can keep track of all of the modifications, upgrades, problems the equipment have had, and what changes you've made, or maybe what workarounds you've created for the equipment at each location. Leave the book there. Maybe put a note on the outside, equipment notebook, do not remove, or it's something to make sure that the maintenance people don't think somebody left it behind and they toss it in the trash. Make sure that people know that it's important, and encourage other people to view it and maybe modify it if you feel comfortable with that, so that you can work together to make the equipment better, or your understanding, or the understanding of your team on the equipment to be better. Command line basics. I'm going to pause the screen just for a second and close my door here. Hang on just a second. All right, thank you for that moment. I just needed to make sure my dog was out and comfortable. Okay, so here we go. Command prompt overview. When an operating system does not work, the technician must input commands from a command prompt. Commands are used to bring up a Windows tool. Various ways to access the command prompt when a computer is functional. You can search CMD and hit enter. We can just do that right here. CMD, CMD, that stands for command. So I just searched for it, and I clicked on it, and I hit enter, and here's our command prompt. You can also type command and hit enter, and note that when this option is used, the keyboard arrow keys do not bring up previously used commands as they do with the command. So what they're talking about there is I can type dir and then type cd, actually cd ... goes backwards one, and then I can use my up arrow to see previous commands. You can see the commands changing there. Sorry, my window can't be bigger. But that is the command prompt and how to move around. You can go to accessories and you can hit the command prompt. You can go to accessories and command prompt. in Windows 7 and 10, and then you can access the command prompt tile in Windows 8 and 10. So you might have an icon or a tile in Windows 8 that is the command prompt. So that gives us our command prompt. And when you open the command prompt, you get standard privileges. It allows users to do some basic commands. But if you want to have administrative privileges, you have to right-click on the command prompt. You have to right-click on the word. Let me see if I can. Can I move this? No, I can't move this. Let me switch my screen. Let me switch my screen. To the main window. Okay, let's see if that works. Okay, so now you see my main window. So when I hit search and I search for command prompt, I can type it in here again. I already found it, CMD. And then I can right click on that and choose Run It Administrator. Now, when you do that, it's going to ask you if it's okay, which I think is kind of silly. But then you now have access to a higher level of command prompt than if you were just clicked on it. So now you have access to do some additional things. All right, and you can see in the title it says administrator command prompt instead of just command prompt. Okay, let's switch back to the other screen since that has our PowerPoint. Share content. Back to 4. Okay, well, that was painless. I think I might try that again in the future. When I have multiple screens and I have a lot of things going on here, so it probably helps. Okay, run administrator. That's all that says. That's what that big remember, if you're trying to do something under normal user privileges and it's not running, then try to do it as running as an administrator. Okay, command prompt basics. Drive letters are assigned to hardware devices. When a computer boots, for example, the first hard drive always is the letter 7. I like to say always, but that's only true 99.99% of the time. Sometimes you might have the operating system loaded on multiple hard drives, or you have multiple operating systems loaded on multiple hard drives, and you might have your, let's say you have a Mac operating system. Well, let's say you have Linux loaded on your C drive, and you have Windows loaded on your D drive. Then of course you will see the C drive, but that won't be your main or first hard drive. It'll be the D drive that is your Windows drive. So you got to be careful about that, and you don't know what your technicians are doing, what your users are doing. So just verify that. But I'm only seeing the D drive as the primary drive one time in 40 years of being a computer technician. So it's not common, but it is possible. The colon is part of the device drive letter, so it's C colon, not just the letter C. All communication using type commands begin at the command prompt or simply a prompt. For example, F colon backslash greater than, or C colon backslash greater than, or C colon backslash Windows greater than. That's what the prompt looks like. File groupings are called a folder, a GUI environment, or a directory command prompt environment. They have a picture of that on the next page. I'll show that to you. The starting point for all directories is the root directory, always the C drive. Like I was talking about, not always the C drive, it could be the D drive, but most likely the C drive, and a subdirectory is created over that. So here we have on the F drive, that may be your USB drive, for example, you have a folder called test, and then under test one, and under test one, you have subfolders. Subfolder 1 has subfolder 1, file 2. Subfolder 2 has file sub 2, file 1, file 2. These are folders in the second subfolders. These are files in the first folder. These are files in the third subfolder. And that's how we create files. I think I mentioned to you my USB drive. Let's see what drive letter my USB drive is. It is the H drive, and that might be worth looking at. I wish I could make this bigger though, because it's going to be hard, especially if you just have a small screen. So for example, I can change directory H : and now okay, I'm going to hit pause here for a second. Let me fix this. Okay, so it isn't CD. CD is change directory. So if I want to go to the H drive, it's just H:. Now I'm in the H drive, and now I can do a directory, and I can see all of the folders that are on my hard drive, including the folders that I'm currently teaching in. So again, I can, from that drive, I can do change directory, courses taken, and then I can do a dir, and now you can see that I've taken classes at Capella, FSCJ, St. John's River State, University of Mary Washington, going all the way back to Webster University, my master's degree. I still have all of the classes that I took all the way back to my master's degree on my drive. That's interesting. I haven't looked at that in a while, but those are courses taken. And then if I go into change directory FSCJ, and I do a dir, you can see here's all the courses and the names of all the courses, right? That's just moving around inside of the, you can make directories, you can delete directories. I'm going to do that, I'm not going to do that here, but you can work inside of the command prompt. Let's move that out of the way. Let's go to the next screen. And you can see that they talk to you about dir lists all of the files and directories from where you are at the prompt. So within that folder, in this case, within the G drive, you have subfolders. Actually, you have files. You have dinfo.txt. You also have directories named Chipdale, Kotlong, photos, and classes, all in as separate folders inside of that drive. The root directory in this case is the G drive, and then these are all files and subfolders within that G drive. Other common commands, including make directory, delete for deleting a file or a directory. I think you can do, I don't want to, yeah, I guess I can do it. Let's see if I remember. So we're going to change directory dot. That moves you backwards, and then change directory dot again. Now I'm back at the H. I'm going to make a directory named fun. Let's do test, and then I'm going to do a dir again, and you can see now I should have a folder called test. There it is right there. So I made a directory named test. And then within, now I'm going to delete test. And then it's going to ask me, am I sure? I'm going to say yes. And now I do a dir again, and I have deleted the test folder. Okay. Why didn't let me just try that again. Delete test. Yes. Okay, it's still there. Can I change directory to test? Okay, so change directory dot. Delete, let's see, it's remove directory test, and then dir. All right, so I deleted everything that was inside of test, but I didn't delete the directory itself. To delete the directory, you have to do an RD, remove directory, and then remove the directory. All right. What else they got here? You can type text or batch. You can type into text, or you can save a file as a bat file. That is when you're creating your files in a using the command prompt instead of inside of our GUI, say opening up the text editor. You can copy files. You can use copy, xcopy, or robocopy. Copy will we'll just make a duplicate of the file. Xcopy is used to copy and backup files and directories. And then robocopy command enables you to copy a directory, all of its contents, and all of those subdirectories and their subdirectories, as well as each attribute. That's robocopy if you want an exact copy of a folder and everything that's in it. The attrib command sets, removes, or shows the attributes of a file or a directory. And let's go to the next screen. It shows you an example here. So if, for example, you have, if you're not sure what command question, what the command prompts are, then you can do a slash. You can see it here, dir /question mark. And what that does for you is it gives you a list of all of the options that you have. So I can do the same thing with copy. You do /question mark, enter, and now these are all the options for copy. It's unlikely that you're going to remember all of the commands for all of the options. In this case, we're looking at directory, the command directory, and all of the options for directory. And here it lists you, if you do directory /A, it displays the files with specific attributes. Or /B, it uses bare format, no heading information or summary. /C displays the 1000 separator and file sizes. So there's a lot of minute details that over time you may be, maybe you're looking at a lot of data in ones and zeros and in dollars. And you're like, man, I really wish I had the comma format. Well, there's a way to do that, but you're probably not going to remember that. But if you do dir /question mark, it'll help you to remember that. All right. Lots of commands that you should know inside of that command prompt, the CMD window, including I showed you the ... to go backwards, change directory, check disk, that's to check for hard drive errors. Command is like CMD, except it has different options. It just lays out a little bit different. Copy, dir to do a list. We have exit to exit out of the current command that you're in. msconfig to show, for example, all of your configuration, your IP configuration, for example. We can do that. We can do msconfig. MS. So when I typed msconfig in there, I actually got a system configuration window allowing me to do a diagnostic startup, maybe to control what loads in my boot when I turn on my computer. Services startup, what starts up. And it's telling me now they want you to go to the task manager to see what starts up. And you can see all the programs that boot when you turn on your computer. You can turn some of those off. You should go ahead and look up each one of these commands and get a feel for it. The more you know, the more you're going to know when it comes to using command line. And command line can be much faster. If you're good at command line, it can be much faster than GUI. If you can do the same thing in GUI, you're more comfortable in GUI, that's fine. But there are reasons to know how to use the command prompt. All right. Scripting basics. So a script is a group of commands in a file that automates a particular task. The benefits of having a script is it saves time, it ensures consistent operation, it provides flexibility. Scripts are interpreted, carried out one line at a time, contrasted with a compiled program, which is a program that has to be turned into machine language before it can execute. I have examples of that. I am currently, let me open up Python. So here I have Python. I just loaded Python on my computer, the newest Python program on my computer yesterday. It's 3 point. Again, it's really hard for you to see, and there's no way for me that I know of to make this window bigger. I apologize. So here inside of Python, this is an interpreter, meaning that if I type 4 plus 5 and hit enter, it gives me 9, right? It does it as I am working with. So if I type, put a first num, I make that a first num is a variable, meaning it represents a location on the hard drive, and I type equals, and first num I make 4. Let's make it different. Let's make it 3, and then I just put 3 in the variable first num, and I can do second num, and I can equal that is 7. And then now I can add first num plus second. By the way, this is what's called camel case, when you leave the first letter of the first word lowercase and then all of the other letters are capitalize the first word. You can see I added the variable first num and second num, and I got 10. So it really, Python's a really easy program to work with, and it works the way you would want it to work. Now this, again, is interpreted. You can make this a compiled, if you will, program that runs when you want to run that program. So, for example, yesterday I worked on a program that a Python script. Here, hang on, let me find that file. And I'm just looking for Notepad. All right. So here is a small program to show the percentage of majors compared to minors that are inside of a class, not majors. And this is written in, it can be written in a text, your Notepad. in any text editor. And then it can be then saved with the .py. You can see it right there, the py. That makes it a Python language. It's as easy as that. Anything starting with a £sign is a comment, and you should use lots of comments in your scripting. Then here's that print, and you can have, without going too far into it, basically I'm printing something on the screen here, and then I'm printing a blank line, and then I'm getting information from the users. So num majors is input, and then I say in text, enter the number of IT majors in the course. And then I also ask them to enter the number of non-IT majors in the course. And I save those as integers, meaning numbers. Python has this odd feature where when any variable that you add into the program, no matter what type of, no matter when you enter it, it's entered as a script meaning text. And so then if those numbers that I added earlier, well, if it wasn't added, no, it was added as a variable. I wonder why that worked for me. Anyways, but here I have to say that it's an integer to be able to turn that to enter the number as an integer. That's what it is. And then calculate the percentage of IT majors. All I do, I create a total in class where I add those two majors. I take the percent majors equals the number of majors divided by the total in class and multiply by 100, round it to 2 places, do the same thing with the other. And let's see, and then I print out what the answer is. So let's see what that looks like when I run it. So I am going to go back to my IDE Python, the learning platform, and I'm going to open that file. And it shows me in an environment that I can modify and save before I run. And then I just go to run the program and I run it and see it asks me what's the total number of IT majors. So that, let's say that's 13. And then what is the number of non-IT majors? Let's say there's 6 people just taking it for fun. And then it tells me the percentage of IT majors is 66%, and the percentage of non-majors is 68% and 31%. So a very quick script that I ran showing you the program using Python. So that's quick and easy, something little that you can play around with. Network Chuck, awesome videos on how to write and program. He has an entire programming course in Python that I highly recommend. I am working through that myself to try to teach myself some new things about Python. But anyways, so that's the difference between an interpreted, where it's actually carried out as you do it, or compiled. The second file that I showed you was a text-based file, and it ran the whole program. That would be an example of a compiled program. Now, scripts can be written in different languages. I showed you Python, but it can be as simple as a bat file. Anybody that remembers the beginning of computing back in the 80s and 90s might remember the autoconfig.bat file and the config sys file. Oh man, I spent so much time in those batch files, because when you turned on a computer, the computer used the autoconfig sys and the config back, I forget what they are now. I'm talking 30 years ago, so those memories are a little hazy. But those were bat files, and it's what Windows used to use when you turned on a computer. PowerShell, those scripts end in PS1. awesome program, PowerShell. You will know PowerShell before you are done with your training here at the school, because PowerShell is the Windows equivalent to Linux, and Linux shells are CLI scripting is really powerful when you're working on network servers. So when you're working with servers inside of the business that you're in, the company you ultimately get hired from, if it's a big business, they're going to be using Linux for their servers, and you're going to be using scripts and this Linux command line to interact with that database. Most likely, because that's the number one server software that's out there. Windows is now falling behind because Windows is quite expensive, and of course, Linux is almost free, virtually free, depending on which version, which distro of Linux you're using. I talked about Python already. There's also VBScript and JavaScript. And my Windows operating system, I'm sorry, my Office example in Excel, that was a scripting language as well. And some of you might be familiar with VBA because that is the scripting language that Microsoft uses when you build a macro in Excel. My earlier example, it will actually save it in VBA, and that's how you edit the macro. So it helps to learn how to script. I could show that to you, but I'm not sure if that would be helpful or confusing. So we'll come back to that if I find that useful in a little bit. Environment variables controls the environment in which programs run. In Windows, the environmental variable has a name and a value. WinDir, W-I-N-D-I-R, it's stored in C:/Windows. The WinDir is a variable that represents the Windows program. The value is C:/Windows. The path is the environment variable that tells the program all of the directories or subdirectories of where to look for specified files located within the program. So you would, for example, go to let me open up the directory for Windows. So here we can see the programs that are loaded on the computer under the C drive, and you can see all the programs that you have loaded, in my case, under program files, and you can go, and from there you can scroll down within there. So, for example, I can go to Cisco, that's not a good example, Microsoft Office, and I can go to Office 16, which is the newest one. It looks like I still have some files from the older operating system on my computer, probably just some variables left over from the last installation. You can see we're in it doesn't even look like that's the right program. So it might not even be there. I might have to look a little deeper. That doesn't really matter though. But here are all of your variables that are loaded on the computer. Now, when you go within Windows, I'm going back to the C drive again. Within Windows, I'm running Windows 11, so it's a little bit different. I'm looking for the system within Windows. There we go. So here, within Windows, I have a system folder. And hopefully you can't use any of this to hack into my computer. Here's system folder. And if I want settings, I can modify the actual. Well, actually, all I have system32 is where all of your actual configuration is. Again, you don't want to just come in here and start messing with the files that are under system32, because you mess with the wrong file and your Windows isn't going to operate anymore. So a better way to get there is probably by using the control panel. And remember, you can just type control to get to the control panel. And then inside of the control panel, you can go to advanced system settings. You can go to advanced system settings. I'm going to freeze this and find that. Hang on a second. Okay, so just there's a window in between system, here's system, and then advanced system that I don't really want to record and put out on YouTube. So I'm not gonna show you the in between windows, which is where you click on advanced, you click on system, then you click on advanced system, and then here this is where you click on advanced, and then you click on environmental variables, and there's all sorts of controls that you have here to control the way your Windows operating system works. Again, I'm not going to scroll through this too much on my computer. You get to play around with that in the simulated environments of your uCertify and inside of your NetLab. Now, I want to say to you, inside of uCertify, under the labs button, there's a whole bunch of labs for module 14. Completing those labs is not directly worth any points in this class, but those labs are going to have you actually interact with the software that we are covering in these two chapters. Let me show that to you so you can understand what I'm talking about. And those of you out watching this on YouTube, it might help you to understand why we use the uCertify software. Not only does it have the ebook. This is the ebook, and you can go through the entire content. Right now we're on module 14, Introduction to Operating Systems, and you can leaf through it just as if you had the textbook. But also, there's a whole bunch of hands-on labs. The hands-on labs are located under hands-on labs, and you scroll down to the module we're currently working on, which is module, we started with 14, now we're in 15. And you can also click over here to 14 and it narrows it down. All these labs are for the module we just did last week in the previous video. So for example, when I was talking about BitLocker, you might want to actually do the lab, and you can actually walk through the steps of BitLocker, or using Cortana, or enable branch cache. I barely touched on that in the last video, but all of these are all labs that you could do that would help you to understand the content. Now, there's no labs for 15, the one I'm covering today, but I think module 14 labs apply for example, PowerShell. We talk about today creating a loop in PowerShell. So we talk about PowerShell in this chapter. So perhaps these labs are for 14 and 15, and they're maybe a little out of date. But anyways, that's uCertify. And completing those labs is what's going to help you to be able to do the assessment that I have due this week, which is Lab 2, Part 2. This is the assessment, and you have to actually go through and complete the assignments that are listed here. Now, the good news is if you really don't know what they're talking about with PowerShell, for example, all you have to do is click on the arrow down below, and it walks you through the concepts that they're testing you above. So you actually have somebody right there with you that's showing you how to do the assignment. So it's not it's challenging if you've never done it before, but it's there's somebody to help you. This is how to open and run PowerShell. When you're done with this, you move on to the. It looks like that is. Then you go to the next one, and here's this is the second question, if you will, and there's a video down at the bottom for that one. So Certify is definitely helpful when it comes to setting you up for success, because it actually shows you, even though they call it an assessment, they actually show you how to do it down below. So don't get overwhelmed on that. I'm going to close that now and go back to our PowerPoint. There are two types of environmental variables. Those are system variables and user variables. System variables are global and cannot be changed. They're used by all of the user accounts. User variables are settings specific to a user, such as where the temp files are stored, what the background picture is, how often it changes. Those are the environment that you have set up, the display settings are set up for example, what your what's the size? You guys help me out in chat room. What's the size of when you change the? It starts with the P. You change the. God, I hate forgetting words. Aspect ratio. So what your aspect ratio is, you can change that under the environmental user settings, so that it's just for each individual user has a different background, a different, maybe, some people use glasses, some people don't. So maybe you need a larger text for some people than others. Syntax for scripting changes a little bit based on which script you have. So for example, I showed you Python, where it was just simply print and then hello world. And I had to put it within parentheses. You notice me do it automatically, because within parentheses, this indicates that this is text that they want printed. If I didn't put parentheses around it, it would try to interpret the word hello as a variable, and then the second thing that it would assume hello is a variable, and then the next thing it would try to make hello, and obviously that's not what we're trying to do here. Actually, that comma would be interpreted as well as separating variables. So my would probably be a second variable, and then friend would be interpreted. Our JavaScript would be console.log, and then the scripting, the rest of it is similar. At the end, though, notice we need a semicolon. We didn't need that with Python. In a batch file, you just type it out without any parentheses. And shell script, echo is a command to say print it on the screen. And notice in shell script, you have to put parentheses around the words that you want to type. In a batch file, you didn't even need that. Constructs, sequence. Code is executed one line at a time from top to bottom. That is important to understand when you're writing a batch file or a script. It starts at the top and moves slowly down, one command at a time. If it runs into a problem, it will stop, most likely. That's if there's a syntax error. If it's a logic error, it will just continue on. It won't understand that your syntax, that your logic was incorrect. The color of the sun is black. Right. Well, if you type in black, it's not going to understand that that black isn't the color of the sun. At least I don't think the color of the sun is black. Color of the sun might be yellow, white, red. I don't know, depending on how you look at it. But it's probably not black. And so that would be a logic error. Not a syntax error. A syntax error is if you type in one of these commands. Let's say you type in print. Let's say you forget the semicolon at the end. It's going to give you an error message. Let's say you mistype the command at the beginning. It's going to give you an error message. That's a not a logic error. That is a syntax error. English teachers teach proper syntax, if you will, the proper way to say something. Selection, certain lines of code are run if a specific condition is met. That may be a conditional statement. If, for example, if your grade is above 70, do this. If the grade is below 70, do this other thing. If it's above 90, print an A, and 90 or above, print an A. If it's could be layers of conditions, so you can have nested if statements were usually run backwards. So if it's below a C type, set the variable to F. Right, below 60 or below 70, set it to D. Below 80, below 80, set it to a C. Below 100, and then the last one would be the else, if you will. You get to the end, it's not true, it's false. That would be your A. Would be everything that's above 90. Repetition, doing the same thing repetitively until you get to a certain point. And that could be, it could be a while. It could be where you are testing if a variable, if let's say you tell the user to input the score for an exam, and they type a word, then you would evaluate the word and say that's not a number between 0 and 100. You would prompt enter a valid grade, and then somebody would type -5, and hopefully that's how you score. And then it would see, you would test that, and it's like, nope, that's not valid either. And it would give you so while it's a not correct, you would repeat until it finally is correct, and then you would move on with the code. You can also do a for example, enter the number of grades you have, 3, and then that 3 is entered as a variable. The variable would be the number of grades, and so then you would set a for loop, if you will, that's called a loop. If you were to set a for loop, then the variable would be 3, and you could have it iterate 3 times. Let's see. So a student in the class recommended an example of a couple invalid entries that if the program doesn't test for invalid entries, my example of a grade was 0 to 100. What if they put a word, or what if they type a negative value? That's an example. But what if they don't test, and you're setting up a bar, and the bar is hang on just a second. Okay, so I had to make a change for the heating on my CPU. It's overheating a little bit. The example would be like a customer walks in, asks for the bathroom, and the bar explodes, or the QA tester comes to a bar and orders 1 beer, he gets 1 beer. Orders 3 beers, gets 3 beers. Orders yes beers, and 128,000 beers gets ordered, because you don't know what's going to happen. What would happen if you ordered a word worth of beers? And so then then programs can do all sorts of weird things, and that would be that would be a logic error. Your program will work, so the syntax is correct, but the outcome is incorrect because the logic of ordering a word worth of beer is going to create a problem. So anyways, that's an example. Let's make sure you're still going. Yes, you are. Good. Let's continue. Program variable. I showed you a variable before. We was using camel case, and it was first lowercase num, capital N for first number. In this case, they show you camel case as well. I can zoom in on inside of a PowerPoint. I can't zoom into my command prompt because when I hit the PowerPoint, it goes away. But anyways, my number, this is camel case, and that's considered a variable. And then they loaded into that variable the word 23. I added single digit numbers, and then I added the variables together. So an integer is I like to call a counting number, but it actually could be negative as well. So it's 0, 1, 2, 3 into infinity, and then 0, -1, -2, -3 into infinity. So those are integers. They can be positive or negative. Floating point is any number that has a percentage. So if you divide 3 by 5 or 5 by 3, you're going to get 5 by 3, you're going to get 1 point something, right? That's point something is a floating point number, meaning that it has something to the left and something to the right of the decimal. Now you can have 1, 2, 3, and you can have them be in floating point. It could be 1.0000 or 2.000. So sometimes when you're writing a program and you are using integers and floating point instead of integers, you might be okay but you can't really do it the other way around. You can't have a floating point. I'm sorry, you can't have a result of division, for example. You really shouldn't ever have that as an integer, because if you divide 5 by 3, you're going to get 1 point something, and then that would be a floating point, so it would truncate. So if I set my result to be an integer and I divide 3 by 5 by 3, the result is going to be 1, because 3 goes into 5 one time, but because the result is an integer, depending on the program, you're either going to get an error message, or you're just going to get the integer portion of the result. Now, there's a way to get also get just to get the integer part of a floating point number, or just the fractional point of a floating point number as well. So if I just want to know just the 1 point something, if I want to know just the 1 and have that return, there's a way to do that. And if I want to return the fraction of the number, I can do that as well. But you need to have a floating point as the result to be able to then take a part of that floating point. You also have text. Those are called string values in Java and inside of our Python that I showed you earlier. Anytime you have text, usually within brackets in most of the programs, quotes, not brackets, quotes, you have text values. That's what tells the program that it is a word that it has to pay attention to. The value of that variable is the data contents at that specific memory location. So you call a variable, and in that variable you put whatever type information that you are trying to save. So if you set a value to integer, then you can put numbers in there. If you for example, in Java, if you have a value of, I showed you in Python that you can just set a variable and you can just put something in it. And the variable is dynamic in Python, which makes it interesting, meaning that variable could be a number at one time, integer, or it could be floating point, or it could be a text. You can make the number 1 the text value of 1, not a numerical 1. And there's reasons why you would want to do that. But that is that ultimately they're just showing you on this slide that you set a location and then you can put something into that location. It is mailbox. A variable is the name of the mailbox, and the value is what the notice is that somebody put in the mailbox. If you want to give it, if you want to think about it like that. All right, so let's go here, and you declare a variable like I did when I just said first num, and I gave it a number. I declared that number, and here they're showing in Python, you just type my var variable name and then equals what. In Java, you would have to be, variable, under the variables, you set my variable name. In batch, you set my variable to 0. And in shell, it would be script colon batch file, shell script, it would be my variable name equals 0, similar to what we have in Python. So just different ways to set variables. You do not need to know how to program in this class. But our assignments are very simple, and both batch and shell scripts are very easy to write, and they're very similar to writing in the English language. Just follow the rules presented, the examples presented, you'll be fine. Don't worry too much. Here are those data types I was showing about, talking about strings. Being the numbers that words and numbers that are dealt with as text. So if you put print and then open parentheses quote, if you want words, then you would say print the words blank, close quote. I showed you the example. Do I still have it open? I don't think so. Anyways, integers are whole numbers. I already explained that to you. 1, 2, 3, negative 1, 2, 3, and 0. Floating point is anything that has a decimal place. Not used in scripts much, but they are used whenever you do any kind of calculation. And I don't know, you might, if you had a script that was creating an average of a bunch of numbers, for example, like if you wanted to do if I wanted to run a script to figure out what your letter grade is, I would use a floating point, because again, averaging out two numbers, unless it just happens to end in a single value, like 4 divided by 2, or the average of 4 and 4, all right, now you're fine. But what if you have the average? What if you have the average of 5 and 10, right? That's 7.5, and that would be a floating point number. Alphanumeric characters 0 through 9, punctuation marks and symbols must be supported by the program. Each program supports different alphanumeric characters. All they're saying is A through Z, 0 through 9, and punctuation marks and symbols are different, can represent things, but they also are what you can use as strings and integers and floating point. So here, they give some examples of setting variables. This was the example I said earlier. Num1 equals 3, num2 equals 4, num result equals num1 plus num2. Super easy, right? And then print num result because you set the variable num result when you added 1 and 2. That just went into the memory location named num result. And you print num result and you get 7, right? Here you get the same exact result, except in Java, you have to call it as a variable, so you're naming it a variable num1 equals 3. And by the way, you're not saying num1 equals 3 as being a comparator. You're setting the variable to 3. That's what that means. Set num1 to the value 3. It's not saying num1 equals 3, like the MPG equals 35 miles per gallon. It's not that. It's you're saying the variable here. Batch files, setting variables, and then shell. We have similar set num1 equals 3, and then seeing the result, you have to use the / for setting, and then some pound signs in there. Got a little work ahead of you to learn multiple languages. Don't worry about that yet. You will learn slowly, and if you don't already know how to program in multiple languages, and that's what you want to do, believe me, you'll learn, and it'll be good for you. That's what they keep saying to me. I gave you an example there for numbers. Here are some scripts, and notice that you can add a Python. You can add a username Joey Jones, welcome, result, message, welcome Joey Jones, right? Now notice the space right here. That's necessary because if you didn't put a space here, these words would be right next to it. J would be right next to an E. So it's welcome space. Sometimes you have to play around with your scripts to have it show and display exactly the way you want it to show. But anyways, the result would be welcome Joey Jones. Let's see, script. Here we have the same thing. Remember, in JavaScript, we needed a semicolon at the end, and we need var at the beginning saying their variables, and then console log, and then the result. The reason why it's result, by the way, is because we set the variable result. This isn't a function or this isn't a function here. This is just the name of the variable result that we picked. We could have named it anything we want. We could have named it complete message. Remember, no spaces, camel case. So complete message, all one, it would say print complete message, and then you would get the same exact result, just a different variable name. Here we have batch files. Notice no parentheses necessary around words. That's interesting, a little bit different, where you did need it in the other 3 to show where the text begins and ends. And then notice that because we didn't have the ability to add a space over here, we had to add parentheses with a space in the middle here. So this is the first word, Joey Jones, here. I'm sorry, welcome here, and then add to it a space, and then put in the username, which is Joey Jones here. So welcome Joey Jones, you get the same result. And this is how you have to write the result. And then script is similar, just a little bit different in how you use words set and batch and set. Script use set instead of nothing in Python, and variables in JavaScript. And then here to show or display a message a little bit different as well. Anyways, comments. When you're writing a program, one of the most important things is to write comments as you are writing the program. And the reason why you do that is because you are going to get to the point where you might be writing a code that's thousands of lines long, or you might be working for a big corporation that already has a code that is millions of lines long. It really is. Windows, for example, has hundreds of thousands of lines of code. And there are people a team of dedicated people. Their job is to maintain the Windows operating system. There is a team to maintain the Google uh, uh, not variable, I'm forgetting the word. Hate that. But hang on a second. I just needed to put you on pause. The algorithm, the variable, the Google algorithm. There's hundreds of, there might be multiple people that maintain that code that could be thousands or hundreds of thousands of lines long. Anyways, so as you're writing your program, you want to put comments that explain to you later why you did what you did. Or I like to think when you get promoted and you move up in your company or to another company, but you move up, the next person that has to look at that code doesn't have to try to figure out why you did what you did. Right. So the better the comments, the more better frequency of the comments, the easier it will be for either you to remember what you did later or your replacement to be able to understand what you did and why you did it. And then hopefully they continue and make comments of why they changed what you did when they got the job. So whatever. In Python, it's a £, one or more lines starting with the pound sign. JavaScript, it is two forward slashes, or if you want multiple lines, you can start and end with a / asterisk. Batch files, either put the command rem to remove, or use : 2 colons before the text that is your that are your comments, and then shell goes also uses a hashtag. So I like to think whenever I'm working with a program, like right now I'm working with Python, I like to think along the lines of Python. If it can be a little confusing if you're jumping between programs. So let's say I spend 15 weeks teaching or learning Python. Then all of a sudden I jump into a Java class and I have to read and write Java. I need to do some brushing up to remember how to do it. And it might, if I've done it enough, I just need to look at the code and I'm able to see the differences. In this class, our requirements for you to write a batch files are pretty easy, okay? But it does get you along the lines of writing your first code if you've never taken a programming class before. Here we have operators. Now, because we think about it, because we use equals to create a variable or to put some sort of text string or a string, an integer, or a float into a variable, we just use the equals. Remember, I told you, it just doesn't mean it literally equals the two equals. It means put this in that other location, in that memory location. Then we need something for when we do want to indicate equals. And in most common operator for that is the double equal sign. And the batch file command is EQE, and the shell operator is -EQ. Not equal is bang equals, which is the exclamation point. They call it bang in when you're programmer, because saying exclamation point is too many and takes too many syllables and too long to say it than just to say bang equals. You can see the rest of this table. The less than, equal to, greater than equal, all makes sense. You'll get used to the batch file commands and shell operators when you are working with your batch files or inside a PowerShell. Selection structure, a single alternative. A test is performed. If true, the test condition is met, the next line of code is executed. If not true, the program skips down to a predetermined next command. So remember I was talking to you about loops earlier, and I was talking about grades. If this equals that, or greater than or equal, I was talking about grade equal, greater than or equal, do this. Otherwise, do something else. And I told you you can have nested ifs. The double equal sign is how we, oh, here they show greater than or no, this is frustrating. Here they're not saying greater than or equal. This is just the poor choice that they used for bullets. So ignore that greater than. Here they're just talking about the double equal sign. And it's a comparison indicating equals, or this equals that, and if it's true, move on. If it isn't, then skip to a different command. For most programming, a single equal sets the value. I told you that already as a variable. The double equal actually compares two values. If you have the dual alternative, that's what I was talking to you about. If this, else that. If it's this, do that. Right? If it's this, if the name equals Jonas, double equals meaning equals, as in the comparator, equals Jonas, then print user found. If it's not Jonas, then print user not found. You can do nested ifs as well. That's on the next slide. I got ahead of myself earlier when I said it. If it's greater than 90, print congratulations, you get an A. If it's, but if it's not, go to the next line. If score is greater than or equal to 80, yay, you got a B, right? Now you don't have to look at all the rest, because as you're moving through, if it's greater than 90, you don't have to look at 80, 70, 60, because it's greater than 90, you get an A. If you got an F, if you failed the class, then each one of these layers is evaluated, and then finally else at the end says, you failed the class, right? Or in this case, they're being kind and they're just saying you've earned an F. There can be compound conditions as well. That's the AND operator and the OR operator. You can even use a NOT operator. So the AND operator returns true if and only if both expressions are true. An example is on, they don't show an example. Here. Example of the AND operator. Given x equals 15 and y equals 8, z equals 2. So if x is greater than y and x is greater than z, then return true, right? Because both of them have to meet. If they are not both true, then it returns a false, because only one of the conditions is set. Okay, so and both have to be set. Or if I had x is greater than y or x is greater than z, return true. And then everything is true except for when they're both wrong, when they're both not true. So it returns a false if and only if both expressions are false. If one or the other is true, then it's true. Or if they're both true, it's true. And then a not operator simply flips the result of the expression. If the expression would have been true, then it's not gives you a false. If it would have been false, then using not instead gives you a true. If not true, right, you get the idea. All right. Here they talk about loops. X equals 5, count equals 1, while x is less than 11. Print times x and then increment. This is a shortcut to incrementing. You could say, instead of saying count plus plus, you could also say count plus 1, which would add 1 to the count. Count equals count plus 1. You would have to type count equals count plus 1, because that would be count plus 1 would then replace the word count when it's count equals count plus 1. Hopefully you understand that. But by using plus plus, you just increment the count by 1, and then it says, and then the next, then it goes to the next number. So it doesn't actually, x equals 5. So count times x. So the So you would then get the second number, and the count would be 2 because you incremented it, and then you incremented it 2 times x, 2 times 5, and the result would be 10. And then you increment it, so x, then the count is 3 at that point. Count, it's less than 11, so you would type 3 times 5, and now you're at 15. You get it. You're counting by 5 in this case, all the way up to less than 11. So where would it end? Would it end at 55? No, it should end at 50 because count as less than 11, which means that it should go to 50 and stop, because we set it to 1, so it started at 1, and then so 1 times x is 5. The first iteration would be 5, and the last iteration should be, the count should be at 10. 10 times 5 is 50. It should stop. And the next time around, it would be, the count would be 11. The count would be would be the same as 11. So it would end with a space. So at the end of 5, 10, 15, 20, all listed above each other, then the last line would be a space. Hopefully that makes sense. Here, Java doing the same thing. For count equals 1, count to 11, count plus plus, meaning increment, and then print count times 5, and then end with the space. I like to think Python's easier to understand, but once you're programming in Java, you're going to like Java better or more than you like Python. I've been told. My language is Python, so so for me, Python makes a lot of sense. It's easy to learn. That's why I picked it. But you might find that Java is easier, or C++. I heard it's really hard. The first time I took Comp 1, I earned an A the first time. I just took it again to see what's changed in 10 years. We used C++ when we learned Comp 1, COP 1000 10 years ago, and that was challenging. And I worked really hard to pass that class. It was less hard. It was not as hard when I took COP 1000 the second time. First of all, we used Python, but also the concepts were similar. The good news is once you learn one program and how all the constructs, syntax, and variables work inside of your logic works in one language, then all you're doing is changing how it's laid out in the other languages. Other languages have different capabilities. That's why, and they might be more powerful than Python. But Python is what we use in Cisco networking. So that's why I focus on Python. All right. I already explained while loops and for loops as well. Basically, how they repeat. While loop, while this condition is met, do this. Once it's it repeats until the condition is no longer true, and then the loop would be do it so many times. Remember, I talked about that already. PowerShell. This is Microsoft's open source cross-platform, and it uses camlets. For example, get location, gets the current directory, move item, moves a file to a different location, and new item creates a new file. When I went through this course years ago, I think I came out of this course thinking that this was my most useful topic that I learned in the course, but it also was pretty much the first thing I forgot about after I no longer was using it. When I was using it in the course, it was like, oh, okay, I get it. I understand how that works. But then after the course was over, pretty much forgot all about PowerShell, except when when somebody on the internet tells me that I need to go to PowerShell, or run a Windows shell command, I understand what they're talking about. And generally, you're just jumping to the commandlet for whatever it is that you are needing to do. anyways, you're going to do a little bit of that in this class, and you're going to learn that. Anyways, that again, at the end of the glossary is a whole bunch of terms that you need to become familiar with at the end of chapter 15. I should add those to this slide so that the people out in the on the internet know what we're talking about. But for my class, you can just go to the end of the chapter and you can see those. I've also been told, by the way, that there is a PDF for both the textbook and the lab book that's floating around on the internet. So you may want to look for this textbook as a, if you're not taking my course, in my course, you need to have you certified. But if you're just kind of learning along out on the internet, I can't provide you with the PDF of the textbook. That's wrong to the author. But what you do on your own moral structure, you decide whether you want to buy an ebook someplace or if you want to download the PDF, just look for it if that's what you feel comfortable with. Anyways, my students have to purchase the book or at least the ebook. So the author is getting paid by, and you can also buy this textbook out on the internet really inexpensively. I think I looked it up and it was $15 buying it used. And so I encourage that as well. Just look for the complete guide, complete CompTIA A+ guide to IT hardware and software 8th edition, and what you cover will match what I'm talking about in the class. All right. That is it for today's presentation. I appreciate you being here, and I know I'm talking on a high level. I really want you to understand that it's important when you come to class to come along with the open idea that I'm either filling in blanks if you've read the chapter, or I'm kind of introducing you to the topic so that when you're reviewing the chapters, it makes more sense. Programming is such a huge field, and I am not a programmer, but I do understand that when you're dealing with technology, it really helps when you're a technician to be able to at least write scripts, and that's where Python has come in handy for me, and hopefully you come out of this class understanding a little bit more about scripting languages and scripting. We'll get into more as we move deeper into the course, so don't think this is the only time you're going to get to see this. We'll cover more of it later. But if you watch, whether you're in class with me and you're watching this as a recording, or you are out on YouTube, please thumbs up if this has been helpful on the video. Give me thumbs up and comment down below if you have any questions. One student, not thumb, you guys are funny. My students in class are giving me thumbs up right now. Not exactly what I meant, but that was funny. I appreciate that. When you're out on the internet and watching this as a recording, then that's where you give me thumbs up, or subscribe to my channel so you can easily find my videos and you'll get notifications, especially if you put a check in the box for notifications, click the bell, and it will notify you when I release the next video. That could be useful for all of you in the class. As I'm moving through this course, I'm recording the videos, and so you'll be notified when the next video has been released. All right, that's it for now. I'm going to stop the recording, and I appreciate you coming to class. Thank you so much. I appreciate it. I will see you next week when we get into, I believe, chapter 16, but we'll see when we get there. Thanks.